Can start then, please.
I'm going to start here.
Okay. Thank you then. Bye.
Yeah, yeah, yeah.
Your audio is clear, but I could not see anything over there. What about the video?
Uh,
Yeah, yeah. Now it's clear.
yeah.
Fine.
Okay,
Yeah, go
sir.
ahead.
Okay.
Okay, okay,
So
okay.
I'm
Fine.
clearly audible now, huh?
Yeah. You're clear, and video is also clear.
Okay, fine, sir.
Okay, go ahead. Bye bye.
So, good afternoon, everyone. So, we are about to start our today's session. So, today, we'll be discussing about the unloading and the loading of different types of tools, and also we'll repeat some portion of the measuring system that we have discussed yesterday, called as Bloom system. Uh, then we are going to load the workpiece onto the table, onto the machine, uh, and if that's done, then we'll move to another session. So for now, here if you can see, uh, here we have got different types of tools that are already loaded onto the tool magazine. So, uh, so the first column here tells us the location of the tool. So here we have this the tool name. Then we have other parameters like the length and radius of the tools. So in the at the location number one, we have a boring tool having a length of 210.794 mm and a radius of 25 mm. So now we are going to unload some of the tools, and we'll load them again onto the machine, and we'll see how this process is going to be done. So for now, here also we'll see that a tool is actually assembly. It is an assembly of some parts, like we have tool holder, we have collet, we have the cutting bit. So we will also disassemble some of the tools, and we'll assemble them, and we'll see how that is to be done. So so here I'm going to unload uh, I'm going to unload this end mill. uh, okay, so just a moment. So we are going to unload some of the tools. So the first tool will be our the first tool will be our drilling tool that I'm going to unload. So it is at location number 2. So I simply select that tool and tap the unload icon here. Then here you can see a message that the magazine loading door is open. So we'll directly move to the tool magazine compartment. So here you can see here this tool is at the pocket 2. Also, you can see here this arrow. It tells me that this tool is ready to unload. So I simply have to hold the tool and then press a button, unloading button here, the clamp. So after pressing this button, I am able to unload this tool. So we'll be unloading more tools. We'll be unloading some more tools. So again, if you can see here, so there is no tool at pocket number 2 now, and this the tool details are at the bottom. So here we have a serial number, the pocket number of 30, and you will find these details at the end of the locations that are present on the machine. So here you can see we have all the details of the drilling tool, but it is not loaded. Similarly, we are going to unload some other tools, like we are going to unload end mill. The tool name is end mill 34, having a length of 133.702 mm and a radius of 4.983. So we are also going to unload this tool. So simply we will select it and simply, just a moment. Okay, actually, the door is open. That's why we got an error message here. Now we'll again select the tool and simply we'll tap the unload icon, and the magazine loading door is open now. So you can see here, now this end mill that I have unloaded is at that location where we have this arrow mark. So means that this tool is ready to be unloaded. So I simply push the button, hold the tool and just unclamp it. And I'm supposed here to again press the button actually to complete the process. Okay. So for now, we have one more tool that is unloaded. So similarly, we are going to unload. I think one more tool that will be a different tool. So we are going to unload this spacing tool. It is actually, or we are going to unload this longest tool. That would be better, I think. So simply I'll select it, click unload icon, and just unload one more tool. Okay. We'll be unloading one more tool called as tapping tool. I'll simply select the tapping tool, click on unload. The door is open. I'll just press the button, hold the tool, and then close the window. So we have got different types of tools here, as you can see. So this is our milling and milling, or I can say the side milling cutter. Actually, it is an inserted milling tool. Here we have inserts screwed on the periphery of the tool. So what we do? So a complete this is a complete assembly actually. So once these inserts are worn out, uh, we simply we simply change them by unscrewing the screws that are assembled to this whole body. So simply
You are not audible, sir.
Am I audible now, sir?
Yeah.
Okay, fine. So once these inserts are worn out, we simply remove them by unscrewing the screws that holds these inserts on the whole body. So I'll just show you. I'll just unscrew one of the inserts so that you will get an idea. Okay. So here you can see this is the insert. It is a carbide insert that is mounted on the whole body. So we actually hold these inserts with the help of screws. You can also see the screw here. So these are mounted on the periphery of the holder. So here, once these inserts are worn out, we just can here, if you can see, we have got two cutting edges here on the opposite sides. Once this edge is worn out, we can use the another edge on the other side. So simply we unscrew and then we mount it again onto the body, onto the holder. So here the design of the holder is such that uh, the insert gets aligned, I can say, automatically, because the design is like that. So I just have to screw it tightly. Okay, that's enough. So this is a milling cutter. This is one of the tools that is available with us. So we simply change the inserts here. Then we have different types of tools that have got different mechanism, different holding mechanism, I can say. So here you can see this is a tapping tool.
Drill.
So this tool, we are using this tool if we want to make threads. So this is a tapping tool. Use it to make threads to perform threading operation. Then we have this is a drilling tool. So this is used to perform a drilling operation. If we want to make holes on our workpiece, then we'll use this drilling tool. And we have one more tool here called as end milling tool. So this is called as end milling tool. Actually, we have got cutting edges here at the end as well as on the periphery of the tool. Like in case of this inserted tool, this cutter, it can only cut at the periphery. So there will be no cutting at the end. But here, if you can see here, we have also got some cutting edge at the end, and we have got cutting edge at the periphery also. So now, for now, we
So
are
what is
going to
periphery, sir?
the
Audible,
outer
sir. What is periphery?
boundary of the tool, the outer diameter. That is the periphery.
Okay, thank you.
Yeah, it's not a continuous periphery. We have got here some number of edges. So we have got actually here four number of edges. So on the periphery, we have got one, two, three, four. So we have got four edges here. So it can be different for different tools. So here we are going to disassemble this whole body, this whole assembly. So we'll simply hold this tool on the tool boy, clamp it here. So this complete assembly is made from is assembled. Different parts are assembled actually to make this complete setup. Actually, ना असलं शेअर आता थोडं. Yeah, that's what. नीचे वाला. You have to hold the. I'll just hold it. Yeah. No. सही बात. आपण त्यांच्या क्वालिटी हम आपण क्वालिटी से कम ये. It is actually tightened enough, so I'm not able to unscrew it. So I'll be getting another tool. Just hold a second. So this is also end mill tool, end mill cutter of different diameter. This has also got four number of fluids, four number of cutting edges. So this is also a end mill tool, cutting at the end at the periphery. But this is of different diameter. So I'll be loading this onto the tool boy. So now you can see here the different parts of a complete tool. So here we have got this folder. This is one of the parts. Then we have another part. This is called as collet. Then we have a mocking part called as I can call it as a nut, and this is actually the tool that is holded through this assembly. So this is a end mill that is holded by this assembly. So here first we'll have a look on this tool. Uh, so we have some parameters like here we have got four number of cutting edges. This is a end mill, so it can cut at the periphery as well as at the end. Also, there is one more parameter, one more specification of this tool that is called the OD. That's called outside length. Outside length means the length through which the cutting is possible. It is the length, or I can say it is the depth. So we'll measure it here. So here, this is the cutting length actually, the total cutting length. So I can go up to, I can say this is 30 mm, 30.33, approximately 30 mm. So I can go this much of deep into the workpiece uh, to perform a cutting operation. So this is the cutting length for this end mill. So I can say here, I can while if I want to machine a component or workpiece, I can go a maximum of 30 mm deep. That will be the maximum limit I can go to perform the cutting operation there. So that is called the outside length or the cutting length of a particular tool. So we are also this part is called as the shank of the tool that we are using. So this part will be the shank, this part will be the cutting length. So after that we have this holder. So these holders come with the codings. So here we have, this is ER32 type of holder. So we also have got ER25 holder. There, here we have used ER25 holder. So it depends on the diameter of the collet as well as on the diameter of the tool that I am going to mount. So this is ER32 type of holder. So here you can also see this is a collet. So collet is selected on the basis of the shank dia. So we'll measure the dia here. So it's around 12. So the shank dia is 12. So I'm supposed to select the collet as per the shank dia. So here also you can see this collet can hold a tool or having diameter of 11 to 12 mm. So we on the basis of the shank dia we have selected this collet, and also it's also written there that this collet is for ER32 type of holder. So it can hold a tool having a diameter from 11 mm to 12 mm. But we prefer to hold a tool of higher side, that is 12 mm of dia. Then we simply have this nut that is used to complete the assembly to hold the collet as well as to hold the to hold the okay. So to hold the complete assembly, we'll be using this. We can call it as a nut. So it actually holds the collet, and I can say it actually completes the whole assembly. So now we'll be assembling it again Simply I'm holding the holder on the tool boy. Then we insert this wallet onto this nut. Okay, it should be flat. You can see here it should be flat. There should be no taper, or there should be no angle or taper, I can say. It should be flat. Then we'll be inserting this tool from the front side, and I can there is some extra length, uh, that portion, that much of length is the cutting line, and we have also got some more length that I need to keep out of the this pollet surface. Then we are simply going to mount it here, holding this tool. Okay, with the help of spanner. It is also written on the spanner that it is to be used for the type of holder. So we tight it enough so that there will be no slipping of the tool. Okay, I think that much is enough. So now this is the complete assembly, the complete tool ready for machining. So all other tools like this and mill, here we only have the different diameter, the lower diameter. This is a I'll check it. Yeah, this is 8.5 mm diameter end mill, and this is 12 mm diameter end mill. Then so this is a tapping tool. It is a M12 tapping tool. M12 tap here, uh, mounted on the collet. So this is mounted in the similar way, and also this is a drilling tool. It is also assembled in the similar way, and here we have this cutter. We have this milling cutter. Here we are simply changing these inserts while once they are worn out. So what we are going to do now, we'll be loading these tools again onto the machine, and we'll see how to load these tools with the complete data. So first, I'm going to load this hand mill. So what I have to do, okay, so I'm going to the tool is screen. So here you can see we are having tools at pocket number 1, 4, 9, sorry 8, 9.
Nothing. The green went completely blue. It got blanked out.
Am I visible now, sir?
Hi.
And,
Yeah.
and okay, fine. So we are also having tools at pocket number 29 and 30. So now we are going to load this and mill 100 is the tool name, and this is the length here, and also the radius is 5.99. So I'm going to load it. I am supposed to write these details actually. If I'm loading a completely new tool, but these are already loaded onto the machine, we'll just select them to save our time. So I am selecting this tool and then selecting this row, then tapping on load icon. So it tells me here that the location number 2 is available for this tool to be loaded. So I can change this location also, but by default it is providing me the location number 2. So I'm going to load it at location number 2. So I'll just bring the tool, open the just a minute. Okay, I was supposed to click the OK, open the door, and here you can see we have a pocket number 2 right at the arrow. So I can hold this tool like this. Okay, then push the button again. Okay, and check it rigidly whether it's tightly loaded onto the uh, pocket. So I'll just close the door. So here you can see uh, we have loaded and mill 100 at pocket number 2, having length of 149 and radius of 5.99. So in the similar way, we are going to load other tools. Now we are going to load and mill 34. I'll just select it, click the load icon, press OK. It shows me here that the pocket number 3 is available. Okay, I'll just click OK. Again, we have to push the button first.
Again, the screen got blanked out. Yeah, the screen is back. Dean?
Am I visible and audible now,
Yeah,
sir?
yeah, both. Yeah, fine,
Sorry for the inconvenience, sir. Yeah. So this is the tool, handmill 34. So here I need to take care of the machine. Don't know whether it is a handmill tool or not. So I need to make sure that yeah I have got the right tool to load on that position, because once the tool gets loaded, and I have kept it as the name and mill. So the machine will take it as and mill. So I need to be careful while I'm loading these tools. So I'm loading it here, just clicking, pressing the button, checking it, closing the door. So again you can see here uh, that the Anvil 34 is loaded at pocket number 3. Okay. Likewise, we have got 3 more tools. I'll make it a bit fast. So I'm going to load tapping tool. Just click the load icon, click OK. So the location number 5 is available. Then I'll just open the window, uh, push the button here. That is the actually the hydraulic clamp. Uh, and there is also a mark on the holder that tells me that this mark should be at the bottom side. So keeping that mark on the bottom side, inserting it onto the pocket, pressing the button again and checking it, closing the door. And now here pocket number 5 is showing the tapping tool of other specifications as well. Now I'm going to load long edge tool, the inserted tool, just clicking the OK here, and the location number 6 is available. Closing the door. So first I'll load one more tool as drilling tool. So I'll select it, click on load, OK. So the location number 7 is available for this tool by default. Oh, sorry. Checking it. So here also you can see here that pocket number 7 was assigned in, and I can cross check it here that yeah, this is pocket number 7 here. So I am loading into the right pocket, and I have to make sure whether the tool I am loading is the right tool that I have selected. So I have selected a drilling tool. So yeah, this is a drilling tool loaded at pocket number 7. Oh, okay. So this was about loading and unloading of different types of tools. First, we'll have a look here. Yeah, we have Anvil 100 at pocket number 2 and Anvil 34. These are the two names by which we call these tools into the program by their names. But I have to be sure whether the tools which I have mentioned in the program are the right tools. Say for example, if I'm calling Anvil 100 of here the radius is 5.99, approximately 6 mm, and the diameter will be 12 mm. So I have to I need to be sure whether I'm calling the right tool while performing some operation. So here we have loaded all the tools. Then we have tapping tool at pocket number 5. We have long edge milling cutter at pocket number 6. We have drilling tool at pocket number 7. So, and we have also got some other tools here. What we can do here now, we can assign these pocket numbers permanently to these tools. Okay, say for example, I have an Anvil of at pocket number 2, I can permanently assign this pocket to this particular tool. So otherwise, if I'm not doing that, then this admin can once I call the tool and complete some machining operation, then the tool, if it is not a permanent pocket for that particular tool, then it can go to some other pocket. Say for example, at pocket number 12, it can be loaded. So if I'm not making it a fixed pocket, then there will be a there will be random locations for these tools. Okay, so but if I have to make it a fixed pocket for a particular tool, then what I'm going to do? Okay, so here I simply get the option in tool magazine icon that if I want to permanently assign this pocket number 6 to long edge milling cutter, then I simply have to mark it. So it tells me that tool on fixed location. So once I use this tool for to carry out some operation, then this tool will be loaded back into the same pocket number 6. Okay, if I am marking it as here as a fixed pocket. So for now, if I am not doing it, then this tool can go to any pocket out of 30 pockets. It can be anywhere. Okay. So for now, I'm making this long edge. Actually, this this is to be done for tools having larger diameter. So at that time, we want the fixed pockets. Likewise, you also can see we have two tools here at pocket number 29 and 30. So these are actually the fixed pockets assigned to these tools, because we are not going to use these two tools for any cutting operation. That's why we kept them separately in separate pockets in fixed pockets. So that's why they are marked here as fixed pockets. So this master will also have a look on these tools once we'll perform this work of setting. So these are at fixed pockets. So once the probe which I'm going to use to take the work offset is called, then it will again move back to the that particular pocket, that fixed pocket. Okay. So this was about loading and unloading of the uh, tools. So now our other another topic will be on the loading of workpiece onto the machine, onto the work table. So yeah, we'll be doing it by now, I think. So for now, I'll first show you different types of clamps. The clamping devices actually that are used to mount the workpieces onto the work table. Just give me a minute. Okay, we'll have a look on some of the uh, clamping systems by which we clamp our workpiece on the work table. So here, this is a work table which have got some T slots here. 7 number of T slots are present on this work table. So what we have done here, we have folded this voice. This is called a voice, having one fixed jaw and one movable jaw. So what we do, we first clamp this voice onto the work table. Then we use this voice to hold our workpiece. So this voice is use it to hold flat workpieces. In general, I can say we can have flat workpieces or we can have cylindrical workpieces. But this voice is used to hold flat workpieces. So to hold cylindrical workpieces, we have different types of voices in which we have uh, more than 2 number of jaws. So this voice is clamped on the work table with the help of these clamps. Okay, so there are 4 number of clamps. One, two, three, four. So I'll just give you the idea. So we are going to uh, hold this workpiece. So this is the workpiece. It's a bit heavy. So in the coming sessions, we'll be going to machine this workpiece. So this is a flat workpiece. You can see the sides are flat here. So to hold a workpiece on this type of voice, we need to have two flat sides. So here we have got, so every side here is a flat side. So we can mount it uh, in any position actually. So here what I'm doing, I'm simply putting this workpiece between the jaws of the voice. Okay. Then this one is a movable jaw, and this movable jaw can be adjusted. I can adjust it as per the dimensions of the workpiece. Then okay, I'll tight this. I'll tight the jaw with the help of some spanner, and make sure it is tightened enough so that it may not slip out of the jar. Okay, so by this way we hold our workpiece onto the table, and there are also a variety of clamping devices available for us to hold our workpiece, because we can have complicated shapes. We can have complicated shapes of the workpieces that we are mounting, that we are supposed to machine. So that's why we have a variety of clamping devices, and I think you can search it on internet, and you'll find a variety of clamping devices available. So simply, so by this way we can hold this workpiece on the work table, and we can here perform this 3-axis machining, or if you are supposed to perform 5-axis machining. So for now, or if I'm going to perform 3-axis machining, uh, then it's okay. But if I have to perform 5-axis machining here, then for that I need more rigid clamping, because at that time the work table is going to rotate. This it is going to swivel. Okay, means there will be some rotation in the B as well as in the C axis. So for that reason, my clamping should be tight enough so that my workpiece should not slip out of the voice. So here, if I can see, yeah, for 3-axis machining, the clamping is rigid enough like this. But if I have to perform this 5-axis machining, then this type of clamping is not rigid enough, because I'm going to rotate it, and the weight of the workpiece uh, is very much here, because the height is more, the dimensions are more, so the weight is actually more. So there are chances, if I rotate this to some angle, say for example 45-degree angle, like this, then there are chances it may slip, because because there are also cutting forces that are acting on the workpiece. So there are chances that this workpiece will get slipped. So for that reason, we I need some more rigid clamping system. So for that reason, what I have done. Okay. So for that reason, I have made two slots here. This is slot one, and another slot is at on the opposite side of the workpiece, as you can see. Okay, so we have got two slots here. Fine. So what I am going to do, I will directly clamp this workpiece onto the work table. I don't use any means of holding this workpiece onto the table, like here. This vice is mounted on the work table. So I will simply put this workpiece onto the table, and with the help of these clamps, I am going to hold this workpiece on the table. So this will give me more rigid clamping, because I'm not using any means by which I'm clamping this workpiece on the table. I'm directly clamping it on the work table. Means it will give me more rigid, more strong clamping. So then in this case, if I'm going to clamp it like this, so here I can perform 3-axis machining, as well as I can perform 3 plus 2 axis or 5-axis machining here, because here the clamping, here the workpiece is directly clamped onto the work table. Okay, so because we are going to, in our next sessions, we are going to perform 5-axis program, 5-axis machining. So for that I need some rigid clamping system, so we'll be just clamping it directly onto the work table. So before that, I'll be removing this vice. Okay, and I will show you how I'm going to remove it. Then we are going to clamp this workpiece onto the work table. Okay. No. My. Okay, so I'm going to unclamp this vice. Okay, so this is the tool that I'm going to use to unscrew the nuts and bolts. Simply I'll keep it like this. So they are actually tightened enough so that there will be a rigid clamping. So simply, okay. So I have unscrewed all the four nuts here. Okay, just simply we are removing these clamps from the side. Okay, and I'm also going to show you this the clamp that we are using to mount this voice onto the work table. So simply here we have got one nut, and this is a T type of nut that is used at the bottom side. So this is also of the cross section is also of the T shape. Okay, you can see here because I have got T slots. So this will help it to this keep it mounted on the work table. Okay, because it simply gets fixed with in the T slots. Okay, so then I have one bolt here, and that is the clamp that I'm going to use to clamp our workpiece. Okay, so this is the complete assembly. So likewise we have four clamps here. So this is one clamp. Mine. Okay, so uh, so this is the voice actually. That is the complete assembly. So we have actually got here two jaws. That is the fixed jaw. That is the movable jaw, and we can also adjust this movable jaw to some location. For that, we have got some holes here. So I will be removing this vise from the table, and actually this is our work table. Here we have got some chips. So this is the actually shape of the work table. So now I'm going to clamp this workpiece directly onto the table with the help of these clamps. Okay. So I think for now we'll be continuing this part in the today's session, uh, and it is all done for today now. So we'll be closing this session, and we'll be tomorrow we'll be clamping this workpiece, as well as we'll be using some measuring system. We'll repeat that the portion. We'll repeat the portion of the measuring system. The that is called the bloom. So we'll be repeating the part of the bloom system tomorrow. And after that, we'll be performing some machining operations like tracing operations, or we have also got some other 3-axis machining operations. So we'll be starting the practical machining from tomorrow, hopefully. Okay. And I wanted to show you one more thing here first, that no, I think it's better to continue this part in the tomorrow's session. So for now, uh, take care. Goodbye, everyone. So we'll see you tomorrow.